Francisco Santiago. For our video project, we're going to use 4 ideas: constant velocity, momentum, kinetic energy, and work, to figure out the force in which an arrow imparts on an orange. Here are some common subscripts we will be using. MA equals the mass of the arrow. MO equals the mass of the orange. D horizontal 1 is the horizontal distance of only the arrow being shot. D horizontal 2 is the distance of the arrow and the orange after impact. This is a diagram of how our experiment will look. First, we will use D equals VT to find the velocity of the arrow, using the distance it travels horizontally without hitting anything and the time it's in the air.
After shooting the arrow directly horizontal from a height of about 4 feet, we found out that it only takes 0.5 seconds for the arrow to hit the ground from that height. Therefore, the distance it goes horizontally is equal to its velocity times the amount of seconds it takes to hit the ground. Using D equals VT in the following subscripts, we find out that VA is equal to DH1 divided by T. By plugging them all in, we get VA to equal 25.6 meters per second.
Using the velocity of the arrow we just found, we're going to plug it into the momentum equation to find the velocity of the arrow and the orange after impact. So V prime would equal the mass of the arrow times the velocity of the arrow over the mass of the arrow plus the mass of the orange.
In order to find the velocity of both the arrow and the orange after impact, we have to use the conservation of momentum equation. mv before equals mv after. Because objects stuck together, the collision was inelastic, so the equation would look something like MAVA equals MA plus MOV prime. After manipulating the equation to solve for V prime, we get V prime is equal to MA times VA divided by MA plus MO. When you plug them all in, there's a substitution, and we get V prime to equal 3.2 meters per second. Very nice.
Next, we will find kinetic energy by using the mass of the arrow and the mass of the orange times V prime we just found with momentum.
After plugging in the following variables, we found kinetic energy to equal 1990.66 joules.
When you see work, think energy, and when you see energy, think work. So the kinetic energy we just found is also equal to the work done. Work equals force times distance, so the force will equal the work over D horizontal 2.
By the way, D horizontal 2 is 0.86 meters.
Resubstituting in all the units that we can measure, this would be the general solution for finding the force.